Welcome to Circles Part 3. This is our final lesson on circles and the angles that appear in them or outside of them. So first, let's talk about the angles that appear inside. That is what we call internal angles. So if we're talking about angle 1, we are talking about this angle right here. Angle 1 is going to be related to two arcs. The two arcs that angle 1 are related to are arc BD and arc CE. You might be wondering, how do I know it's those two arcs? It is because if you take this angle and you extend both of the sides of the angles, you can see that I just made vertical angles. And that is how I know that this angle surrounds my blue arc and this angle surrounds this blue arc over here. So we know that these two angles are the same, so I don't need to use both of them. I just need to use one. So here is the formula. So it is your internal angle is equal to 1/2 of arc 1 plus arc number 2. This is a little confusing, so I'm going to color coordinate it and I'm also going to name it. So your interior angle is what I did in red. It's going to be equal to 1/2 of whatever the first blue arc is plus the second blue arc, and I color coordinated everything. Now let me describe it even better than that. The internal angle in this circle is called angle 1. So angle 1 is equal to 1/2 of the first arc, let's say this one right here, BD. When you write arc, it is the letters with a little rounded hat on top. That's how you say arc. Plus your second arc, which is right here, CE. So in this case, that would be your formula for this problem. So just to give you an example, let's say I say that this arc is something like 60. And let's say this arc is something bigger, like 150. And you wanted to solve for the red angle that's internal. So that means measure of angle 1 is equal to 1/2 60 degrees plus 150 degrees. Remember PEMDAS, you have to do parentheses first. So 60 plus 150. Then take half of that number, same thing as dividing by 2. And we achieved our correct final answer, which is 105 degrees. That is how you deal with external angles. Before we go on to the next one, I just want to say that usually I teach the kids that internal kind of looks like an S. And if you're trying to be nice, maybe looks like a plus sign. You're going to see why I'm saying that, because for internal angles, you need the 1/2 and you need to add. But for external angles, it's going to be different. So let me go to the next slide. Here is an example. So let me highlight this first so we know what the actual question is. They want me to find the measure of the angle RPS. So they want this one right here. Okay. First step is to take that angle I just made, go right here and see what is the angle projecting to in terms of an arc. That means that I can also extend this angle to make that X. That's how I know it's internal, because it's inside, it makes an X, to verify that QT is your other angle. Your other arc. Sorry about that. So here is your equation. Your internal angle is equal to 1/2 arc 1 plus arc 2. And remember, we're only talking about the arcs that are directly across from each other, dealing with the angle. So what I'm going to do is I'm going to say that your internal angle, another name for this one, is going to be what they actually said down here. So I'm going to say that the measure of the angle RPS, which is here in red, and I'm going to say is equal to 1/2. And then what is your arc 1? It doesn't matter what order. I have 201 for this arc, which is arc RS. So RS is 201. And then for this arc over here with the very cute name QT is 59. It doesn't matter what order you put it in. And that is because addition is commutative. Then you just have to add and then multiply by 1/2. So that is what I'm going to do. So measure of RSP is equal to 1/2. Add these two, you would get 260. After you get 260, you just have to cut it in half. Same thing as dividing by 2. You would get 130. So your final answer is 130. It would go right here if you're looking at the diagram. That is actually taking the average of the two arcs. I don't know if you noticed, because taking the average is when you add up all your things and then divide by how many things you had. In this case, we added 2 and we divided by 2 because multiplying by 1/2 is the same thing as dividing by 2. That's how you deal with internal angles. All right, now let's talk about external angles. First, you need to know what are the names of these lines here. This line is called a tangent. This line is also called a tangent because it only touched the circle one time. This line right here is called a tangent. This line up here goes through the circle, so it is not a tangent. It touches the circle more than once. Remember, a tangent only touches it one time. This is what is called a secant. It is secant. And then if you look at the last one, it is made of a secant and a secant. All right, so if you look very carefully, all of these have the same formula. I'm breaking it down for you by giving you the same formula for all of them instead of telling you each one individually and pretending like they're different. So let me tell you what the formula is. First, let me label some things so then you can understand. So I'm going to call this angle A. I'm going to also call this angle A and then angle A. I'm also going to do some highlighting so you guys are not confused. Let's say that this is purple. And let's say this other part is green, since it already looks green. Actually, no, green looks like the other part. Let's do orange. All right, now I'm finally ready for my formula. The formula is that angle A is equal to, and angle A is what is known as an external angle because it's hanging outside of the circle. So angle A, which is, an external angle, 1/2 the bigger arc minus the smaller arc. Okay, you might be wondering, what do I mean? Let me highlight for you. This is the angle that we are trying to solve for, angle A. I'm just gonna surround it a little bit by black so you can see a little better. So this is my angle A that I'm trying to solve for. Your bigger arc is whatever the tangent and tangent line project to. This one as well with the secant and the tangent, and this one. So what I'm trying to say is that, for example, this arc over here has nothing to do with the formula because it's not within the two lines. It's not within the secant and the secant. So your bigger arc is what I did in purple. Your smaller arc is what I did in orange. So take the time to look at it carefully And you'll see that it doesn't matter if you have a tangent like the left one, or a secant and tangent like the middle one, or secant and secant like the third one on the right hand side. It's always that the external angle is equal to 1/2 the bigger arc that's contained within the two lines minus the smaller arc. Notice that this is minus subtraction because we're talking about external angles. The formula you just learned in the previous slide was addition because it was internal. External, you're going to remember to subtract. Notice it still has the 1/2 though, so that's good. Let's go on to the next slide. We have some examples. All right, so first I'm going to write down the formula for you guys again. So here's the formula. Angle X, as long as it's an external angle, is equal to 1/2 the bigger arc minus the smaller arc. Okay, so here is your first one. So this is your bigger arc, this is your bigger arc, and this is your bigger arc. Then this is your smaller arc. Notice that I'm looking within the two lines. It doesn't matter if they're secant, it doesn't matter if they're tangent. And then right here, this is your angle that you're worried about, your external angle. So your first one would be that X, your external angle, is equal to 1/2 your bigger arc minus your smaller arc. Notice your bigger arc is empty. To get the purple, you would have to do 360 because the purple matches the orange perfectly to make a circle. Subtract it by 116 to get your answer. When you do that, you will get 244. So then that becomes your bigger arc minus your smaller arc. Then you just have to do PEMDAS. PEMDAS, you just have to do your parentheses first. So we're subtracting 244 with 116 and you get 128. And then you do 1/2 times 128, same thing as dividing by 2, and you'll get your answer of 64. Let's deal with the next one. I have X, because that's your external angle, is equal to 1/2 your bigger arc minus your smaller arc. This one wasn't tricky at all because they gave us the two numbers. So you're just subtracting 173 and 79. You get 94. Multiply by 1/2, same thing as dividing by 2, and you get 47 degrees. Okay, now we're on to the last one. So the last one is the external angle, which is X, is equal to 1/2 the bigger arc, which is here in purple, minus the little one. So don't forget, those are your arcs because they're contained by the angle. That's what I'm trying to say about all of these. So if you were to do the math on this one, we just are going to subtract, then divide, and you get 45. Those are your external angle examples, and don't forget that this is the easier formula to memorize. If you have any questions, please ask me on Google Classroom or on Remind. This template was from Slide.